like to think of the origins of life as ineffable, as the theologians put it, unknowable. I'm quite content to accept that life did originate, whether it fell in from space, whether somebody put it there, or whether it evolved by itself, doesn't bother me. All the right ingredients are there anyway. I'm more concerned with what happened after it started and how it grew and spread across the planet and then suddenly merged with the planet's own lifeless evolutionary processes to become the system I call Gaia.
Jim Lovelock created the theory of the living planet. Despite total rejection from fellow scientists, he continues to promote his ideas. He's an atmospheric scientist, and his journey began with his reputation for unusual inventions.
Suddenly, out of the blue, I had a letter from NASA in America asking me to participate and design instruments to detect life. To me, this was just like a first love letter. It was that exciting. You see, I've been a science fiction buff ever since I was a small kid. And to be actually asked, me, was just the most wonderful thing ever.
Jim joined NASA in its heyday. Scientists said that they were at the frontiers of human knowledge. Expeditions were being planned to every corner of the solar system.
9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Viking was being sent to Mars, and NASA wanted to know if there was life there, how would they recognize it?
They were looking for the kind of life that we know on Earth. And this seemed odd to me because we had no idea, if there were life on Mars, what it would look like. And it would be pointless sending a detector to find elephants on Mars, just as it would to send one to find elephants in Antarctica. It's the wrong habitat, the wrong place. So I thought, couldn't there be a more general experiment? And that led me to suggest that one looked for changes in the composition of a planet's atmosphere as the best way to find life. Now, the logic behind this was that if the planet had life on it, that life would be obliged to use the atmosphere as a kind of conveyor belt for its raw materials and as the source of raw materials. And if the life used the atmosphere this way, it would be recognizable in the chemical composition of the planet. You see, the compositions of the three terrestrial planets, Earth, Mars and Venus, are very much the same. They were made out of the same kinds of rocks and gases and so on. And they all had water to start with. So if the Earth had never had life upon it, it would be in a state roughly halfway between that of Mars and Venus. And it would be an arid desert, not as hot as Venus, nor as cold as Mars, but very much one of a family of dead planets. The Earth's atmosphere was an amazing and wonderfully anomalous atmosphere. You had gases like methane and oxygen coexisting, which is quite impossible on a lifeless planet. Indeed, the Earth's atmosphere is rather like the mixture that goes into the intake manifold of your car, hydrocarbons and oxygen that are combustible and will give energy, whereas the atmosphere of Mars is just like exhaust gases, mainly carbon dioxide, from which no more energy can be drawn. And it's this difference that I thought would make the best kind of life detection experiment. And I was thinking about the Earth's atmosphere. And it suddenly dawned on me that life has to be a planetary-wide phenomenon. You could no more have a partially occupied planet than you could have half a cat or half a dog. It just wouldn't work. Life has to take charge of its environment and evolve with it. And I suddenly said, you know, it seems as if the whole system is alive in a way. It's regulating itself. And that moment, I remember quite clearly, is when the notion of Gaia first came to me.
Jim's theory of the living planet meant it was unnecessary to go to Mars. He was able to analyze its atmosphere with infrared telescopes and concluded that the planet was dead, an opinion that was not popular at NASA. When his contract expired, he returned to England to develop his theory.
In the old days, thousands of years ago, people used to believe that the Earth was alive. They saw her as a kind of goddess. The ancient Greeks gave her the name of Gaia. Now, the idea behind the Greek goddess so well fitted with the scientific theory. Also, giving it the name Gaia gave me the excuse to have an embodiment like this statue. Now, I'm sure she may not be the classicist perfect picture of Gaia, but she looks beautiful to me, and she inspires me and keeps me going.
Hi, Margaret. Come
Hello,
in.
Margaret.
Oh, thank you. That's all right. You're not late.
Come and meet the guys. Or if you haven't met them already.
Jim never again took a full-time job. Although a member of the Royal Society, he began to part company with the scientific establishment.
If you were an artist, or a novelist, or a poet, or somebody like that, nobody would think it odd if you worked in your own home. In science, there's none of this at all. I'm almost the only independent scientist in Britain. Everybody else works in large institutions, universities, or industrial labs. Why should one expect scientists to work that way? I think it's silly. My favourite thing to use in cooking is liquid nitrogen. Oh, I was even sort of writing a liquid nitrogen cookbook. I mean, if you want to make perfect mint sauce, what you do is to put some mint leaves, fresh mint leaves, in a pestle like that. Pour some liquid nitrogen on. They freeze absolutely right down to like glass. You pour off the liquid nitrogen, just tap them with a pestle, and they all fall to dust. And the dust is at minus 180 Celsius, so none of the flavour evaporates. And then you can make your mint sauce without losing a thing. Same to a garlic. You can crush a garlic clove, just like hit it, and it fractures into millions of tiny fragments. No smell comes into the kitchen. All of it goes in the food. That's real. No kitchen is complete without a container of liquid nitrogen.
Jim derives his erratic income from his books and inventions. He rarely leaves his home and laboratory and has disconnected his telephone. But nowadays the world increasingly seeks him out for his pragmatic advice on the environmental crisis.
They're the last people on Earth to ask for empirical solutions to your problems, because modern science has become so specialized that you've got a situation where there's at least 30 varieties of biologists now, many of whom are quite proud that they don't understand any of the other branches of it, and don't want to.
Jim realized early on that Gaia had important environmental implications. With his own invention, the gas chromatograph, he began looking for changes in the atmosphere of the planet. His reasoning for Gaia had been through strictly scientific logic, and his ideas have, ever since, been dominated by the data he has amassed.
The wonderful thing about the Earth is how just right for life it is, and never more wonderful than on a day like this and in a place like this, with the lovely sea and the sky and the flowers on the cliff top. Now, when I first came to think about Gaia, by kind of looking at the Earth from outside, the thing that struck me most forcibly was how remarkable it was that the Earth has such an amazingly constant atmosphere. You've got this mixture of oxygen and gases that react with oxygen, like methane and nitrogen, staying at just the same levels for tens of millions of years, never changing, always staying just right for life. And the same is true of the sea out there. It's got something in the region of 6% salt in it. Now, if it were a little more salt than that, no life as we know it could live in the sea. It would be too salt. How on earth has it stayed just the right degree of saltiness for billions of years?
Jim set out to explain some of the riddles of our planet. But his way of answering them turned many ideas on their head. Life, he thought, could not exist just within individual species. It would need to include things that are not in themselves alive.
This tree, you may not realize, is nearly all dead. It's actually a live tree. There's leaves on it and it makes acorns and all that. But even so, perhaps 97% of it is dead. The bark beneath my hand is dead. The wood that makes up most of the tree is dead. The only thing that's alive is a thin skin of living cells that goes around the circumference of the tree beneath the bark. Now that's amazingly like the Earth if you think about it. You see, on the surface, the circumference of the Earth going right round is a thin skin of living tissue. Us, the trees, the grass, everything that's alive. Beneath that are the rocks, and above it is the air. And both of them are dead, but really they're part of a living organism, just as the bark and the wood are part of the tree. For you see, all of the air and most of the rocks beneath our feet have been processed through living cells at some time in their existence. So has the wood, and so has the bark of the tree. They're very similar. They're both alive.
One of the more convincing arguments for regulation is that the sun has warmed up by more than 25% since life began, enough to take us from freezing to boiling. Yet the temperature on Earth has remained virtually unchanged. It is a phenomenon known as homeostasis and is unique to living systems. Life has thus not only evolved, but has also found a way of coping with this change. According to Jim, it is because species that assisted this process were those that evolution favored.
When we talk or think about the greenhouse effect, we usually think of it as something that people are doing. Well, it isn't that simple. The greenhouse effect is something that has been with the Earth always, and it's just part of nature. It's an effect caused by some gases, like carbon dioxide, that keep the Earth warm like a blanket. And Gaia seems automatically to adjust the level of carbon dioxide to keep it more or less comfortable for the life that happens to be on the planet.
Carbon dioxide has been pumped out of the air by microorganisms that live in the sea. They've used it to create the hard calcium carbonate shells of their bodies. When they die, the shells remain, and so the excess carbon dioxide has been removed from the atmosphere. And over millions of years, as the shells have sunk into the sea floor, layers of chalk rock have slowly built up.
Now, in these cliffs, there's several hundred feet of calcium carbonate, and it's fascinating to think that every inch of that cliff represents the amount of carbon dioxide that's in the atmosphere now. And yet there are several hundred feet there, so you see how powerful has been this pumping effect of the system. And it's this, I think, that makes it so inappropriate for us to perturb this system now by adding carbon dioxide to the air, in fact, going quite contrary to what are clearly the planet's wishes. Changes in the sun's temperature, or rather output of heat, is one of the major factors that shaped the evolution of the solar system and of the Earth. But there are others. You see, every so often we're visited by things called planetismals, large chunks of rock, some of them up to even 15 miles in diameter, that come in at an enormous speed, up to Mach 60. That's 60 times the speed of sound. And when they hit, they released enormous quantities of energy. For example, one that fell 65 million years ago and is thought to have led to the extinction of the dinosaurs, packed as much energy as 1,000 times that would be released if every hydrogen bomb in the world today were let off simultaneously. And some of those impacts killed off more than 90% of all of the species present, as far as can be seen from the geological records. And yet the system bounced back and kept going. And it seems to be a very powerful system that's able to sustain itself in spite of such impacts. And this is one of the reasons why I think that there is nothing that we humans could do that would threaten the Earth itself. What we're doing is trivial compared with what has happened to it. Although, of course, the things we are doing could cause the death of us.
The history of the planet has been filled with violent catastrophes and dramatic changes in the conditions on Earth. Life has remained because microorganisms continue to operate, converting rocks and gases into the useful chemistry of the planet. But it took thousands of years each time to bring a return to stable conditions. And the more complex species that played no such role died out during these periods of crisis.
I see myself as the shop steward, the trades union representative for the bacteria and the less attractive forms of life. They are the real owners of this planet. They have been here for 3.5 billion years, and without them we have no chance whatsoever of survival. Humans are something very recent, like the froth on the top of a glass of beer.
According to Jim, the story of evolution is the story of its bacteria, and that is where the quest for Gaia should begin.
We've just seen the Natural History Museum, and that deals with the last bit of the Earth's evolutionary history. In fact, if the Earth were 100 years old today, we would be seeing with the dinosaurs the period just about 1 year ago when the Earth was 99. Now here we have a sewage farm, and that I think is a much better museum of Gaia's history. In those tanks over there we have the anaerobic digesters, where there's an atmosphere of methane gas above a world which is very like the world of the Archean. And in these tanks here, the aerators that oxidize the output from those tanks, and that's like the Middle Ages of the Earth, the Proterozoic. Both of them run entirely on bacteria, nothing more than that. Now, that world, the Archean world 3.5 billion years ago, and the Proterozoic world between 1 and 2 billion years ago, still lives on. The methanogens are in our guts and in the mud and all over the world, and the cyanobacteria, the things that use sunlight to keep things going, They're to be seen everywhere in the green stuff around us, in the trees, the grass, as the chloroplasts, the tiny organisms that once were bacteria, but now are part of the leaves of the plants themselves. We're now entering the last phase of Gaia's history, when oxygen became the dominant gas in the atmosphere. Now, it may surprise you to learn that oxygen is one of the great poisons of the world. Now, in Gaia, poisons are nearly always turned to advantage. We don't just submit to them. And this is no more true than with oxygen. The trees you see around us here would not be here had they not, when they were small plants, not able to grow very high, learnt to produce a substance that protected them from the poisonous effects of oxygen, mopped up the poisonous byproducts called free radicals. And that substance was a precursor of what makes the trunks, the bodies of trees, able to stand up, the structural material. It's something called lignin. And without that, there just wouldn't be any trees.
Jim believes that the Gaian system has coped with its own poisonous wastes by finding ways of converting them to safe, useful materials. But it is not the only way that it has dealt with these dangers.
In Gaia, there's no such thing as pollution. The rules of the game are that any species that produces something noxious that adversely affects the environment is doomed. Imagine there's some green bug just down there that decides it will be a neat trick to make chlorine. That bug is not going to succeed. If it doesn't kill itself off, it will certainly kill off its progeny and destroy the environment around it and have no food to eat. It just won't work. Man seems to have broken the rules of the game since we appeared on the scene. And so far, we seem to have got away with it.
To many, the idea of the living planet is a poetic inspiration. But to Jim, it means something quite different. He believes that as we stress the planet with our pollution, it must, like any living system, resist the change. He set out to find what pressures we were creating and how Gaia was dealing with them. In 1971, he joined the research vessel Shackleton on its annual voyage to Antarctica to measure changes in the chemistry of the atmosphere. He became the first person to detect the buildup of chlorofluorocarbons and realized they were a greenhouse gas thousands of times more powerful than carbon dioxide. He concluded that the problem facing the planet was global warming, and according to his theory, there had to be a mechanism keeping the system cool. The Plymouth Marine Laboratory, where Jim is honorary president, had been researching the microorganisms that removed carbon dioxide from the air. Slowly, an extensive body of evidence was building up about these vast algal blooms.
The worth of a theory in science is measured by its testability. That's to say, its ability to make risky predictions. And Gaia, happily, has passed that test very well. For example, in recent times, we were able to predict that climate might be regulated on Earth by a powerful process whereby the algae living in the oceans produce tiny droplets that were the seeds of cloud droplets in the clouds above the ocean. And the presence of white reflecting clouds above the ocean waters is a most powerful climate regulating process. Sunlight is reflected back into space by these clouds, whereas the deep blue ocean absorbs heat. And we made calculations, worked it out, and it turns out that but for the emission of this gas by the ocean algae, there might be very few, if any, clouds at all over the oceans of the world.
The sea algae do not decide to produce this gas for our benefit. It is simply that because they do so, their numbers are stimulated.
Well, it works like this. The algae growing in the ocean are starved of nutrients, especially out in the open ocean. And it must be very frustrating for them. For quite a short distance in the water below, great supplies of nutrient, but unfortunately the top water doesn't mix down at all easily with the lower water because it's warm, and warm water won't mix down into cold water below. Now, if they can produce this gas and produce a cloud above them, the cloud produces an updraft of wind because a lot of heat is released when water condenses to form cloud droplets. And as this updraft occurs, it draws in wind over the surface of the ocean. This stirs the ocean and brings up nutrients below. So there's a direct benefit to the algae from producing this gas and the wind. So perhaps these little organisms out in the ocean are like the trees of the tropical forest, the really truly important organisms that help Gaia to regulate this planet.
The cloud algae effect was only discovered in 1987, and to date, little is known as to the conditions under which it may fail. Even though this discovery came about solely through Gaia theory, and despite growing evidence of Gaian regulatory mechanisms, most scientists still refuse to take Jim's theory seriously.
Biologists didn't like Gaia from the beginning, and they still don't like it very much. The most interesting, and I thought intelligent of their criticisms, came from two biologists. One was Ford Doolittle in Canada, the other was Richard Dawkins in Britain. And roughly what they said was, what you're talking about, a self-regulating planet, is quite absurd. There's no way that evolution by natural selection could lead to any such thing. To achieve it, you'd need to have committees of species that met each year on Mount Ararat and decided on what next year's climate or composition should be. And that, of course, is ridiculous and impossible, so Gaia's a lot of nonsense. And this was a good criticism. It wasn't easy to answer. In fact, it took me nearly a year's thought before I found the answer to it.
Daisy World, an imaginary planet seeded with light and dark daisies, was his solution. He calculated the energy that is absorbed or reflected by the different color daisies as its sun warms up, thereby controlling both their own growth and the planet's surface temperature.
That red line shows you how the planet would warm up if there were no life at all upon it. But you'll also see a yellow line develop, which is how the temperature on the planet will evolve as the daisy species grow and compete with one another. When the temperature reached 5 Celsius, the daisy seeds started to germinate. And in the first season, dark daisies would have an enormous advantage because being dark, they would absorb sunlight and grow better. Dark daisy population would expand, and as it did so, it would warm both itself and its region, and eventually the whole planet. Light-coloured daisies are now able to grow because it's warm enough, and they start competing. And when the star gets very hot, only light-coloured daisies can grow and keep the planet cool. And as you can see, the temperature is very close to 20 degrees Celsius and stays there. And that's a pretty good regulation over a wide range of output of heat from the sun. But soon, the star's output cannot be controlled by daisy growth and the system dies, just like any living system would die if subjected to too much heat. No purpose, no foresight, no planning, no committees, nothing like that were needed to get this model to run. It ran just automatically. And therefore, the criticism of the biologists was wrong. One of the most exciting things to me about these models was the fact that you could not only have daisies, you could have rabbits eating them if you wanted, and foxes that are culling the rabbits. Here is the competition between the species, and they compete nice and smoothly. There's no sign of chaos or mathematical problems. The impact of a planetesimal kills off half or more of all of the species present. But at no point had the temperature risen more than a few degrees one way or the other. The planet was being kept running in spite of the intense damage suffered by the impact. But the really exciting thing is the biologist parameter diversity, which is a measure of the number of species present at any one time. And what it shows is that when the diversity is maximum, that is the time when the model is most stable and is regulating well. Whereas when the diversity is low, when life just begins on the planet, or when it's just about to fail, that's when regulation is least. So for the first time, we have a theoretical biological model which gives a justification for diversity, gives us a reason for keeping the rich diversity of the tropical forests, not just to some sentimentality, but having a solid scientific backing. You should have seen this place about 12 years ago. It was all bare land, sort of typical farmers' fields where they graze cattle on, and where they take everything, trees and all that, down just to leave nothing but grass. And I'm not a farmer, and the question arose, what could I do with it all? And it suddenly dawned on me some 6 years ago that maybe I could turn it back into the kind of ecology that it was before man came on the scene. So what I did was to plant some 20,000 trees, 10,000 on this side of the river and 10,000 on the other side over there. And these were all planted, the 10,000 here, some 6 years ago. And as you can see, they're coming on quite nicely. It'll be a while before they're a forest, but they're not doing badly. What's the point of planting all of these trees from the point of view of the greenhouse effect? It buys us time. You see, a tree may take 50 or 100 years to grow, and we need that time urgently now. We need to take CO2 out of the air, into the trees. If it gets burnt subsequently, maybe we'll have figured out how to do it, or what to do with it, but it'll give us time. The wildlife really has begun to come back, particularly the birds, but also animals like foxes and badgers and even stoats and weasels and so on. And sometimes I like to think there's a bit more to it than that, and that the message somehow gets around amongst the wildlife that it's safe there up at old Jim's place. And it's a comforting thought for me.
Messages about nowadays, don't we?
You've been trying hard.
Anyway, that's great. Okay, right.
Okay. I'm finding it very difficult to distinguish between the myth and the metaphor and the religion of Gaia and the scientific theory, where the old views of the Earth, the ancient Earth goddesses and so on, strangely enough, although they were mythical, have laws which are very similar. They map onto the scientific laws. For example, the goddesses, both Gaia and Kali, the Hindu goddess, were kind, nurturing, feminine, and caring, all those good things, but at the same time they were quite ruthless about their destruction, their punishment of transgressors. Kali was said to drink the blood of humans from a skull, and Gaia might well do the same if we so ill-treat her planet as to make us no longer a species fit for it.
It is the dark side of Gaia that is ignored by many who admire Jim's ideas. He has become a figurehead to environmentalists, to whom the living planet symbolizes all their concerns. But to Jim, pollution is not bad simply because it despoils the Earth. It is bad because it changes the chemistry of the atmosphere. The solutions he sees must come from scientific, not emotional reasoning, although many claim he ignores their political cost.
I was very pleased and honoured to have been asked to give a lecture, and I was especially moved by the thought that the invitation was made knowing that from the radical Earth-centred viewpoint that I've just given you, I had occasionally been heard to say in public that nuclear power was a benign source of energy. It takes something to invite somebody to talk here who says things like that. Often when I speak to sensible and intelligent Greens, I find that their common sense drops out when one mentions nuclear power. And I don't regard it as of any particular danger. I notice in the air around us there's plenty of haze pollution, plenty of carbon dioxide from the fossil fuel burning stations all across Britain and Europe. And I think they represent a far greater danger than does this place. And I appeal to you not to be carried away by the hysterical propaganda of the anti-nuclear movements. We need nuclear power at the moment. We don't want to get rid of it. Let's be glad we've got it and not close it down, because it just does not add to the greenhouse. Mainstream science sees it that as the greenhouse gases accumulate in the atmosphere, the climate will steadily warm. How much, there's argument about how much it'll warm, but there's little doubt that it'll warm steadily and gradually, perhaps at an increasing rate, but nevertheless gradually. Now, Gaia doesn't see it that way. It sees that the warming could be sudden and drastic. If there is a sufficient forest clearance, and at the same time there is a failure of the algal blooms in the ocean to play their part in controlling carbon dioxide, that gas will suddenly rise in abundance in the air, cause a much hotter planet, and with positive feedback hasten those same very processes. Quite suddenly we shall jump to a new stable and enormously hotter state. Most of the middle of it, desert far more severe than anything we know, and the rest of the land largely inundated, because the great ice caps will have melted. A miserable world, and one where the new biota will be evolving to bring the planet down towards a more comfortable state, but taking tens of millions of years to do it. But in addition, one would expect that this change would take place in planetary terms very rapidly, perhaps in 10 or 20 years. And during that 10 or 20 years, there will be the most amazing surprises. Storms of unprecedented severity, climatic changes breaking all records, and things that are quite unaccountable and totally unexpected. We will carry things to the point where some small change, some small unexpected change, will initiate the series of positive feedbacks that lead to the flip. And once it starts on it, of course, it's unstoppable.
Es lebe Deutschland!
Before World War II, when I was a kid, all of my betters in those days knew there was going to be a war, but nobody knew when. And strangely, in the matter of the environment now, most of us realize that we are threatened by something up there ahead, perhaps in the 1990s, perhaps not until the next century. But threatened we are, and it's probably going to happen, but we don't know when. Nor do we know really what to do about it. That's just how we felt then. We felt helpless. Yet, once the war started, there was the most wonderful spirit of inventiveness amongst the scientists, and we were solving today's problems yesterday almost. When I see the riches that science has nowadays and how little that they do with it, I know that given those same kind of feelings as we had back then, that very much more could be achieved to meet the much more serious environmental war that threatens us. The ultimate answer will not come from any sudden breakthrough or some desperate action. It comes from doing all of the things so that the percentage improvement that each one makes adds up to a large enough effect to produce a substantial and useful change. We can use more efficient cars. We can insulate our houses better. But above all, we can use every pressure and every means that we can think of to reduce the pressures on the tropical forests, which I think is perhaps the most important action of all that we can take, although politically probably the most difficult one. If we try to value the forests of the humid tropics in human terms, we think in terms of trees that might have the cure for cancer or some other deadly disease. Or we think in terms of all the cuddly animals and special plants that are in them that could form a gene bank for us. In other words, purely for our benefit. But if instead we look at those forests from Gaia's point of view, it takes on a very different significance. The real value of the forests of the humid tropics is as air conditioners for the planets. Those forests sustain the climate of the region where they exist to a most remarkable degree, and without them the region would turn to hopeless, arid desert. They are probably the most valuable real estate we have on the planet.
In Africa, desertification has already begun, but Jim predicts it will spread throughout the tropical belt. One billion people live in climates sustained by rainforests, but he believes their future could be worse than all-out nuclear war. As the tropical forests are cleared for agriculture, regulation is being lost. The regions will get hotter and hotter, finally making it impossible to support any form of vegetation. Unlike forests, fields do not affect the climate. They do not produce clouds or rain. And the carbon dioxide that crops use when they grow is returned to the atmosphere when they are harvested and eaten.
We may have to begin seriously to consider the possibility that we get our food directly from chemicals. I know that sounds awful, but before you condemn it out of hand, just think, nowadays most of you eat margarine. And in fact, many people will pay a higher price for good margarine than they will for butter because it tastes so good and spreads so well. You see, the chemists can do a remarkable job when they're challenged. We mustn't forget that techniques like genetic engineering can, in fact, grow the tissue of beef in great vats fed from petrochemical foodstuffs. It may sound revolting, but I'll bet, properly done, the product might taste a lot better than the kind of beef that's sold in shops today. The real pollution is people. There's something like 5 billion people in the world, and it's increasing all the time. And this means that we are denying to Gaia a significant fraction of the land's surface. Well, obviously, we can't eliminate people, but we can possibly eliminate the livestock they keep. And the land that is used by these animals is having a significant effect on the ability of Gaia to regulate the planet. And the loss of land to cattle farming increases yearly. I sometimes think that our fall from the Garden of Eden was when we took up farming. I've often wondered, in a science fictional sort of way, if we should consider persuading our genetic engineers and microbiologists to develop a kind of cattle plague, something like the disease myxomatosis that virtually eliminated the rabbit from Europe in a couple of years. Ooh. Ooh. It would be a beautiful world again, not ugly at all, because it would mean that vast areas of land could revert to the natural kind of forests that would regulate the planet so much better than farming fields do. In a funny sort of a way, I value life more than I value human beings. And the reason it's a funny sort of way is I have 8 grandchildren. And I want to see the future world one that is consistent with human beings. In other words, an ecosystem that is still comfortable for them, my grandchildren. And it won't be unless the planet is looked after. It's no use looking after humans specifically. It's no use being like Mother Teresa and saying, take care of the poor, the lame, the sick, and the children. God will take care of the earth. God will not. We must take care, not to so stress the earth that it changes to a state that is no longer fit for us. The concept of Gaia was an experience very like that of the astronauts. When they first went out into space and looked back on the Earth, they saw it as a quite remarkable place, something nobody had ever seen before. And it's a singularly beautiful planet and gives the impression of something living.
Very, very beautiful.
I regard the space program like one of those gorgeous holidays one takes. And when you get back home, you see your home with an entirely new perspective. And it's great to be back there, and you realise how many things there are to be done to put it right.
And I feel fine. Capsule is turning around. Oh, that view is tremendous.
Detection experiment. And I was thinking about the Earth's atmosphere, and it suddenly dawned on me that life has to be a planetary-wide phenomenon. You could no more have a partially occupied planet than you could have half a cat or half a dog. It just wouldn't work. Life has to take charge of its environment and evolve with it. And I suddenly said, you know, it seems as if the whole system is alive in a way. It's regulating itself. And that moment, I remember quite clearly, is when the notion of Gaia first came to me.
Jim's theory of the living planet meant it was unnecessary to go to Mars. He was able to analyze its atmosphere with infrared telescopes and concluded that the planet was dead. An opinion that was not popular at NASA. When his contract expired, he returned to England to develop his theory.
In the old days, thousands of years ago, people used to believe that the Earth was alive. They saw her as a kind of goddess. The ancient Greeks gave her the name of Gaia. Now, the idea behind the Greek goddess so well fitted with the scientific theory. Also, giving it the name Gaia gave me the excuse to have an embodiment like the statue. Now, I'm sure she may not be the classicist perfect picture of Gaia, but she looks beautiful to me, and she inspires me and keeps me going.
Hey, Margaret, come
Hello,
in.
Margaret.
Oh, thank you. That's all right, you're not late.
Come and meet the guys. Or if you haven't met them already.
Jim never again took a full-time job. Although a member of the Royal Society, he began to part company with the scientific establishment.
If you were an artist, or a novelist, or a poet, or somebody like that, nobody would think it odd if you worked in your own home. In science, there's none of this at all. I'm almost the only independent scientist in Britain. Everybody else works in large institutions, universities, or industrial labs. Why should one expect scientists to work that way? I think it's silly. My favourite thing to use in cooking is liquid nitrogen. Oh, I was even thought of writing a liquid nitrogen cookbook. I mean, if you want to make perfect mint sauce, what you do is to put some mint leaves, fresh mint leaves, in a pestle like that. Pour some liquid nitrogen on. They freeze absolutely right down to like glass. You pour off the liquid nitrogen, just tap them with a pestle, and they all fall to dust. And the dust is at minus 180 Celsius, so none of the flavour evaporates. And then you can make your mint sauce without losing a thing. Same as to a garlic. You can crush a garlic clove, just like hit it, and it fractures into millions of tiny fragments. No smell comes into the kitchen. All of it goes in the food. That's real. No kitchen is complete without a container of liquid nitrogen.
Jim derives his erratic income from his books. His journey began with his reputation for unusual inventions.
Suddenly, out of the blue, I had a letter from NASA in America asking me to participate and design instruments to detect life. To me, this was just like a first love letter. It was that exciting. You see, I've been a science fiction buff ever since I was a small kid. And to be actually asked, me, was just the most wonderful thing ever.
Jim joined NASA in its heyday. Scientists said that they were at the frontiers of human knowledge. Expeditions were being planned to every corner of the solar system.
9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Viking was being sent to Mars, and NASA wanted to know if there was life there, how would they recognize it?
They were looking for the kind of life that we know on Earth. And this seemed odd to me because we had no idea, if there were life on Mars, what it would look like. And it would be pointless sending a detector to find elephants on Mars, just as it would to send one to find elephants in Antarctica. It's the wrong habitat, the wrong place. So I thought, couldn't there be a more general experiment? And that led me to suggest that one looked for changes in the composition of a planet's atmosphere as the best way to find life. Now, the logic behind this was that if the planet had life on it, that life would be obliged to use the atmosphere as a kind of conveyor belt for its raw materials and as the source of raw materials. And if the life used the atmosphere this way, it would be recognizable in the chemical composition of the planet. You see, the compositions of the three terrestrial planets, Earth, Mars and Venus, are very much the same. They were made out of the same kinds of rocks and gases and so on. And they all had water to start with. So if the Earth had never had life upon it, it would be in a state roughly halfway between that of Mars and Venus. And it would be an arid desert, not as hot as Venus, nor as cold as Mars, but very much one of a family of dead planets. The Earth's atmosphere was an amazing and wonderfully anomalous atmosphere. You had gases like methane and oxygen coexisting, which is quite impossible on a lifeless planet. Indeed, the Earth's atmosphere is rather like the mixture that goes into the intake manifold of your car, hydrocarbons and oxygen that are combustible and will give energy, whereas the atmosphere of Mars is just like exhaust gases, mainly carbon dioxide, from which no more energy can be drawn. And it's this difference that I thought would make the best kind of life. Like to think of the origins of life as ineffable, as the theologians put it, unknowable, I'm quite content to accept that life did originate, whether it fell in from space, whether somebody put it there, or whether it evolved by itself, doesn't bother me. All the right ingredients are there anyway. I'm more concerned with what happened after it started and how it grew and spread across the planet and then suddenly merged with the planet's own lifeless evolutionary processes to become the system I call Gaia.
Jim Lovelock created the theory of the living planet. Despite total rejection from fellow scientists, he continues to promote his ideas. He's an atmospheric scientist